Can science really teach you important life lessons? Sure, science teaches us everything we know about life, how we exist as human beings, how our solar system works, the laws of physics. But can it provide you answers to those philosophical, emotionally driven questions you ask? What is the pursuit of happiness? How can I find my future mate? How can I be successful in life? I'm going to try to spend the next few minutes trying to convince you of that, but first I want to tell you how I stumbled across this. I had just graduated with my PhD in 2007, and I was given the challenge of teaching general chemistry at 8 a.m. during the winter semester at Georgia Tech. Now, many of you know that it's very hard to get anyone interested in anything at 8 a.m., let alone chemistry. And during the winter, where most people rather be at home sleeping at 8 a.m. rather than listening to me talk about how atomic structure really works. So I had to challenge myself to do 3 things. A, to get them excited about chemistry. B, to make sure that they keep coming to class. And in all honesty, I really just didn't want to get the worst ratings on ratemyprofessor.com. So I started to think of ways to teach them about chemistry that's relatable, because the thing, as we know about teaching about atoms, is these are things we cannot simply see. It's kind of an abstract world. So when you want to teach someone about something that's so abstract, you've got to make it relatable. So what I tried to do was find ways in which I could relate atoms to relationships, for example, or to human behavior. And that's when I started to stumble upon this thing of science can really teach me some things about life. So there are 4 lessons I'd like to share with you today. I'm going to teach you a little bit about the science, because we can't discredit the science, and then hopefully be able to relate it to a life lesson. So the first lesson is about perfection. I am a terrible perfectionist. I mean, I try so hard to turn in everything perfectly. If I'm working on a document, I make sure there are no errors. Even today, I thought I'd go get my nails done, and then as I'm leaving, I look at my perfect nails, and I get in the car, and of course, I chip one. I just can't seem to get perfection to work for me, and this bothered me for a very long time, because if you are a perfectionist yourself, you will appreciate the angst you go through when you find out that something you did was just not perfect. So as I was teaching the kids about these things called enzymes, I realized I need to take a different take on perfection itself. So what are enzymes? Enzymes are proteins. And really the simple fact is that they take something and they make something else. So they take the substrate and they convert it into a product. They're very important. They're involved in multiple processes biologically, such as digestion, metabolism, immune response, and so on. And they have a site, a center in which all of the chemistry takes place. So that's when they can take the substrate, the yellow hexagon, and turn it into the product, the red rectangle. Now, when the enzyme actually does its reaction or catalysis, it binds the substrate. But if you can see in the picture, when it binds, it's not an exact fit. It binds enough to allow it to actually happen. But there are some gaps, as you can see in the cartoon that I've drawn. And eventually that leads to the product. So what happens is, in between, there is a transition state that forms. In that in-between state, the enzyme changes itself so that it binds a substrate much tighter, more perfect. This perfect binding lasts a femtosecond. So those of you that don't know what a femtosecond is, it's a millionth of a billionth of a second. Extremely, extremely short-lived. So perfect binding lasts a femtosecond made me think, maybe I shouldn't be so hard on myself if I'm a perfectionist and I don't get it right 100% of the time. I perhaps shouldn't be saying this, but maybe I had my femtosecond of perfection of giving this talk right now and it's passed. But it made me realize I need to take it a little bit easier. Now, this doesn't mean that I don't strive for my best, and this is always a lesson I taught the kids as well. You always strive for your best, but hey, not perfect 100% of the time. It has to be perfect a femtosecond. The second lesson was about finding the perfect mate. And as Dr. Ziad said, yes, about finding my husband as well. In your mid-30s, when you're looking for the love of your life, your perception on mates changes. You're no longer in your 20s in which you're looking for someone who's extremely handsome like George Clooney, and you're trying to figure out the perfect guy for you. And I made this checklist when I was in my late 20s of what my ideal partner was going to look like. He was going to have a great sense of humor. He was going to be intelligent. He's going to be ambitious and like indoors and not really like the outdoors very much, and because I'm not a big camper at all. And I took that checklist around, and for about 5 to 6 years, I looked for that perfect person and really couldn't find him. At the same time in our lab, we were trying to work on engineering proteins. And the reason why we wanted to engineer them was we wanted to take them, change their natural function, and make them bind something else. So we worked on these proteins called nuclear receptors, which is shown. Just to make it really simple, because I don't want to bore you with my research, these nuclear receptors bind hormones. They're very important in our bodies. Many of you might have heard of the estrogen receptor that's involved in cancer. Anyway, what we wanted to do was take that receptor and change its structure so that it no longer binds the natural hormone, but binds something that we introduce. And so in order to do that, what we did was we spent hours behind a computer looking at the structures of these proteins. They actually look like this. Proteins are very, very beautiful structures. And then what we had to really focus on was the binding, where it actually takes place between the hormone and the actual protein. And we wanted to see and design ideal bonding, because that is what makes things bind together. So we used all of the scientific principles we knew. We included all the bonds. We took everything into account. As you can see, it's quite complex in the binding site. And then we designed these proteins and we tested them. Sadly, after about a year of doing this, 99% of the time we failed. And this really bothered us. How is it that we can't design the perfect pair? And so after a while, we decided to just switch and decided to do this thing called random mutagenesis. We would put the protein inside a solution and just let random changes occur and see if that would work, if we could get one that would bind our designed hormone. And sure enough, it did. And when we went back and looked at that perfect fit or ideal fit that we found, we realized there are some things that made sense and some things that did not make sense at all. And it was the mix of the ideal and the non-ideal interactions that allowed these two things to come together and work. So it started to make me think about, this checklist that I have, maybe it's not serving me well because there are certain things on that checklist that I just don't know about, because these would be things I would consider non-ideal. And 10 years later, when I finally did get married, I love my husband very much. He's in the audience, so I can't say many bad things about him. But I will tell you, he's a combination of a great deal of those items that were on that checklist. But there's several things about him that are not ideal. For example, my husband chases bears, and I run away from anything that moves. So, non-ideal, but with the ideal makes it work. So sometimes what you have to do when you're looking for that perfect mate is to remember there are certain things you just don't know yet. The third lesson is about balance. Now, this is a very interesting concept because we all think we know what it means to live a balanced life. It's an easy thing, right? You know what you're supposed to do. You have a work life, you have a family life. But actually, do you really know what it takes to keep it balanced? And I always try to teach my kids this when I'm talking about chemical equilibrium. So chemical equilibrium is basically that reaction that's shown at the very top. You have these reactants that go into products. The reactants are in purple, and the products are in green. And when you have chemical equilibrium, you have an arrow going forward and an arrow going reverse. That means this reaction goes at the same rate when you are at the state of equilibrium. But what's more important is that the concentration of the purple and the concentration of the green at equilibrium or at a balance is the same. So that means that if you increase the concentration of one side of the reaction, you have to compensate that by decreasing the other side. So I always tell my students to draw out their lives as a chemical reaction. Put the things that matter to you on different sides. So if we were to take a look at my chemical equation, it would be my family, my social life, my personal space, which is very important to me. And on the other side would be my work and volunteer work. And sometimes when I start to feel a little bit off balance, I start to look at the concentration of these things. So if I'm working a lot, which I do often, and I feel that I'm very unbalanced, I try to compensate by trying to perhaps spend a little bit more time with my family. So you take some away, you add some somewhere else. And I think that's really important for one main reason. I have found that I am most content when I live a balanced life. And it's really not about changing the factors of the equation, but about balancing the amount or the concentration on both sides. So my lesson to you is, if you feel you're imbalanced, draw out a chemical reaction and see where you're compensating one over the other. The final lesson is about community service. I was very fortunate enough to grow up in a family in which my parents believed in the concept of giving back. They would always tell us that whatever you do on a professional and personal level, remember that it's not about you alone, that you are part of a bigger community, and that your difference has to impact that as well. But we're living in a very different world today. It's a world of me, it's a world of selfies, it's a world of my agenda. And so we have to remember, though, that that's great, but at the end of the day, you're part of a bigger community, whether it's your family, whether it's your work environment, or whether it's the global community as a whole. And I always get my students asking me this: how do I know that I'm going to make a difference? This is their question to me. And I always try to bring out these chemical processes that our bodies go through. So let's just talk about one, which is called translation. Translation is the way that we make proteins in our bodies. It's a very, very complex process, as shown in the figure, in the yellow part. There are many players, there are many molecules, and there are many proteins that are involved in the process of translation, so it's quite complex. Now, every one of these entities that makes this process happen plays a role. So there are some very small proteins that are involved, such as the amino-acyl T synthase, or there's some big proteins like the ribosome. So scientists, they got very excited when they discovered the structure of the ribosome because it's a massive protein. But the truth of the matter is, you would take away the small protein, and translation does not happen. So what that means is that we are all part of a process. Every one of us plays a part. You can be the CEO of a company, or you can be the janitor, or you can be the mayor of a town or a civil servant. At the end of the day, each of us has a part. And I always try to encourage that not only do we have to do our parts, also, of course, to fulfill ourselves, but we also have to do our parts to fulfill our community. And more importantly, it's the collective efforts of all of our parts that allows us to make a difference. Thank you.